Hello, I'm Andy Smith, I'm General Manager of Element.
I'm John, I'm Director of insightEx Limited.
Hi, we're here today to talk about IEC 60079 Part 14 and the updates that have just been published, and also to make an announcement about our partnership with regards to training. So, yeah, we've known each other for quite a while, haven't we? It goes back quite a while now.
I think probably 10 years.
Yeah, I think it is, isn't it?
That we've been working together now on and off in several different locations.
And also in different relationships as well, because we started off, you were in manufacturing, I was in certification, and we've crossed paths in different ways. And it just shows you have those relationships that go on for many years, don't you?
Definitely. I think this is one of those industries. It's like a really big industry, but a very small world, and you bump into the same people over and over again. So we've bumped into each other a lot, worked a lot over the last 10 years. I'm working again with Jason, who I used to sit next to in a previous job. So yeah, they're really important, building and keeping these relationships, because you never know when you're going to be working with somebody next.
And those relationships as well, it's that knowledge and experience in the industry that is crucial for progression, isn't it? You need to have those relationships and outside of your normal working environment to be able to share ideas, collaborate. And like you say, it's a global industry, but actually it's still a small world, isn't it?
You still find everyone knows each other, yeah. And everyone's a specialist in their own little area. Nobody knows everything, so it's really important building those partnerships and building those relationships, because that's how you get further,
Yeah. And I mentioned in the previous podcast as well, where the knowledge is hard to come by, and in manufacturing, from yourself being in, you know about manufacturing, but you need others who are doing other things like certification bodies who know the requirements of certification, and that's really where this training partnership comes along, because manufacturers know how to manufacture, certification bodies know how to certify. How do you bridge that gap? And that's really through training, isn't it?
That's it. I think manufacturing, there's a big skills shortage in the EX world, and it's been that way for a long time. I think there's this old school mentality that one person knows everything about the EX for that industry or for that business, and they've been there 30, 40 years, but that generation of people are now retiring, and they're sort of taking all their knowledge with them. It's a bit of a cultural thing, but the older gentleman engineer hasn't always been the best at sharing their knowledge and bringing the next generation up. So now we're in a situation where people are taking control, taking ownership of the certification in the engineering departments without that 30 or 40 years of experience, and it's really starting to show that there's a big gap in the industry, and they're trying to replace that one person with another one person. So if you're lucky, you go into a business and they might have one person who knows what they're talking about with EX, and then you're lucky if the rest of the staff know what a hazardous area is, and that's their bread and butter. So what we're trying to do through training and through working with the manufacturers is bring up that level of knowledge, bring up that foundation to a level where everyone at least knows what industry they're in. It's a really strange place where people are manufacturing products and they don't know where they're going, because it's seen as it's the EX guy's problem, it's the authorized person's problem. They know enough to certify the product, keep the certificates ticking over, pass an audit, and that's just how it's always been. I say in one of my courses, you wouldn't have a Formula One team where no one knows the rules, and that's unfortunately, it's laughable to think that you might have one engineer in a Formula One team who knows the rules, but that's the sad reality in a lot of EX businesses, and we're trying to change that through making more training more accessible, more affordable, because there's always been quite a high barrier to entry. Courses cost thousands of pounds for one person for a couple of days, so it's not sustainable. It's not even possible really to train up your whole staff. There's never been that facility available, so that's what we're trying to accomplish.
And it's important as well, I mean, it is a requirement as well. That
it's actually a requirement of the standards, that you pass your audit. You must demonstrate that your staff have competence, but
it's not just to be annoying, is it? There's a reason why you want everybody throughout the process, whether it's design to procurement to production, who understand what they're doing and why they're doing it.
Yeah, so we're trying to prevent explosions and people dying, so it's a fairly high stakes game, but that's what makes it interesting. If you were in a manufacturing business where you're making something else and the stakes aren't so high, like why care? But here, if you do something wrong, you're causing an explosion and people are going to die. So there really is that consequence, like there really is stakes to what you're doing. So it's really important that people understand that, but like you say, if people don't understand the industry that they're working in, they don't understand the stakes, they don't necessarily take that extra precaution. Maybe they use a different material, maybe they use a different part, and all of a sudden, all of this work that somebody's done to make that product safe is out the window.
Yeah, and I've come across this many times in the past where there's just one piece missing, just a lack of knowledge, and a mistake is made. And a mistake is made not yesterday or last week, but years ago. And it only gets found out because that one person who does know comes across it. And it can be a major problem.
Yeah, it's fragile, you know. Having one person in a business isn't a good idea. You need everyone to understand and be pulling in the same direction. So that is a real problem in this industry. It's something we're trying to address. Through this partnership as well.
Yeah, so I'm hoping this is something we can offer to manufacturers, and it's not just the manufacturers who are dedicated to making equipment for explosive atmospheres, but there's also many manufacturers out there who will have maybe only one or two products that are going into explosive atmospheres, but the requirements are still the same.
Yeah, and that's where you find it can be more dangerous, where there's a little knowledge. Some of the bigger EX manufacturers, where it's their bread and butter and their entire business model, they do have these things in place. But if you're dipping your toe in and you're going from making industrial lighting to lighting that's going into an explosive atmosphere, and you don't have that foundation, that's when mistakes happen.
Yeah.
So
it was part of Element. We'd been involved in explosive atmospheres for about a quarter of a century. And
so
some may not be, before Element it was Track, and before that it was TRL, but we've been in this industry for a long time and there's a lot of experience.
Yeah, of course. I've come across Element a lot on the certification side, so working on the standard committees and seeing how people like Simon Barracliff are sort of entwined into the IEC scheme and very knowledgeable. You've got a lot of very knowledgeable people at Element, but on the manufacturing side, you're probably one of the more quiet bodies, so not everyone knows that much about Element. So through doing this and through raising some awareness, it's gonna really help people.
Yeah, I think so. So we're also here to talk about IEC 60079-14, so the new edition. What can you tell me about it?
So there's major changes to the new edition of Part 14, but when somebody says Part 14, what do you call it?
Installation standard, I guess that's what you'd know it as.
So everyone calls it the installation standard, and that's probably part of the problem. So it's always been seen as the installation standard, so it's something that installers do. And the installers go away, they get their qualifications, and the designers don't really know what it is, they don't really get involved. Not many people do. So I worked for a cable gland manufacturer, so cables and glands are a big part of the requirements of Part 14. So it's something that I've been involved with. I've been on the standard committee for probably 5 or 6 years now, developing the new edition of this standard. So I'm acutely aware of all of the changes and what they mean for the industry. But the main point I would say is it's not just the installation standard. It's design, selection, installation, and initial inspection. And the other parts tend to be overlooked because it's seen as it's on the installation side, it's out in the plant that you've got to worry about this thing. But a lot of the important decisions are in the design and the selection part of the standard, especially when it comes to the cable and the cable glands.
So what are the main changes then?
So there's a load of changes in this standard. It's sort of a complete rewrite. There's 5 major changes, and the first one is the change of the title. So it's design, selection, installation and initial inspection. It was called design, selection and erection, but they've removed erection from the title. I can't imagine why. But they've also restructured the standard. So it used to be a collection of requirements in no particular order, whereas now they've been discretely moved into the sections for design, selection, installation or initial inspection. So it's harder again now to just say it's the installer's problem, because it's in the design section or it's in the selection section. So of the changes, some of the most significant are the changes to EXD, cable and cable gland selection. In fact, there's 5 major changes in the standard. The first is the title I've mentioned, and 2 of them are about EXD, cable and cable gland selection. Specifically, the cable and the gland now need to be thought of together. So in the previous edition, there was a cable section, and it said what the cable needed to do. And there was a gland section, and it said what the gland needed to be. And the guidance was famously pretty rubbish. It's vague, it's not conducive to making a safe cable gland selection or considering what EXD is doing, which is it's trying to stop an explosion from traveling up the cable, igniting the atmosphere and causing a larger explosion, which is going to kill people. But there were no questions about the application. There's no real thought going into it. And there's a sort of motivation to not use a barrier gland in the industry because it saves cost. It saves a lot of installation time. You need qualified installers. So there is a big motivation within the industry to avoid barrier or sealing glands, which are much safer, but like I say, they add cost. So the guidance was pretty rubbish. It basically said your cable needs to be round, and if it's 3 meters long, you don't need to seal it. It's a little bit more complicated than that, but it basically comes down to that. So there was, for the last 11 years that standard's been live, that's sort of the culture now, and there's a lot of projects that don't use barrier glands and people know how to avoid using them, which is what they do. So the new standard changes that. It requires a selection based on the application, and they've introduced a new flowchart. So firstly...
Well, there used to be one before, didn't there?
So 2 editions ago, yes, the 2007 edition, which some people may remember, even I'm not, I don't remember that far back. There was a flowchart, it's similar, it asked a few important questions, so like, is it 2C, is there sparking equipment? Questions you should be asking for flame-proof. The consequences, if you don't select the correct gland, you could be causing an explosion. So it's like vague guidance for people who we know there's a low bar of competence around. It's just an accident waiting to happen. So give clear guidance, and then even if somebody's got a low level of competence, they're going to know what to do. So it's still not 100% clear because the standard committee is not perfect and there's a lot of differing views, and I sort of joke that it's been rushed out over 11 short years. But it's taken that long to try and get some sort of agreement and get it published. And there's still disagreements going, and the next edition's going to pick up straight away where the last one's left off. But the major change is that there's now a lot more scrutiny and a lot more detail involved in EXD, cable and cable gland selection. So now there is the fact that you've got to consider them both together. There is the new flowchart you've got to follow, which will ask you, is it a 2C atmosphere, is it 2A or 2B? And you go down different sides of the flowchart and it asks you different questions. And then the cable, if you want to go down the route of not using a barrier gland, has to be tested. There's a new mandatory test called the Annex C pressure test, which is a fairly straightforward test to conduct. It's a 5-second pressure test of the cable there to simulate if there's too many gaps in the cable. If there's too many gaps, you're more at risk of the flame traveling through the cable and escaping. If it fails, you need to use a barrier to seal that from happening. If it passes, the cable is deemed compact enough that it's safe to use without a barrier gland. But it's a mandatory test.
Yeah.
So it's not like you can say, oh, well, the cable's 3 meters long and it's round, like you could in the previous edition. Now, there's a test, it's mandatory, and you have to pass it. So it adds a whole level of complexity. The easy solution would be use a barrier gland. But like I say, there's a lot of resistance to using them, adds a lot of cost, adds a lot of complexity. If you're a plant that has 5,000 glands, that's a lot of cost, you know, a lot of maintenance. It makes it harder to inspect. So there are motivations to not use a barrier gland. I would say, if in doubt, use a barrier gland because it's much safer. But if you want to go down that route, there is now a mandatory test that needs to be conducted.
Yeah. And that's something we can help with as well.
Well, it opens up a lot of questions, yeah. So who's doing the test?
Yeah.
Okay, so at the moment, cable and cable gland selection sort of done in the engineering part of like a feed project, an EPC project. It's done quite high up the chain, and at the moment, in my experience, somebody has a spreadsheet of cables where they're going, and then they'll send that on and say, give me glands for this. So at no point is someone looking at the length of the cable, looking at the gas group, looking at the application, all of the things that you need to do to make a safe selection. But now there is this additional test, so it's establishing who's going to do this test and then making sure it's done correctly. The manufacturers may not want to do it, but you need calibrated equipment, you need a controlled environment, so there's going to be people that need third-party test labs to carry out that test for them. Now, is it the cable manufacturers that are doing it? Is it the equipment manufacturers? Is it the sites? That is something that needs to be established, but it's in the selection part. So really, whoever is putting the cable and gland together, usually the equipment manufacturers or the package manufacturers, they're the ones that are responsible for doing the test. And do they want to do the test themselves and keep that evidence and keep the calibration of the pressure transducer and everything else that they need to do? Or do they want to use a third party and all of the security that comes with that?
Yeah, yeah. And I think that's something that we can help with, just conducting that test. It's fairly straightforward for a test laboratory that's used to doing these kinds of tests.
Oh, of course, yeah. It's a fairly straightforward test to do, but you get, by using a third party accredited lab, you're getting that extra level of security with your test results.
Yeah.
And it's the evidence that you need. So the wording in the standard, because again it couldn't be agreed upon, was you need sufficient reliable evidence to show that the cable passes the Annex C test. So sufficient reliable evidence, sort of a bit of a grey area, but if you're to provide a third party certificate from a UCAS lab or an ICEX lab like Element have, then that's, for me, that's sufficient reliable evidence.
Yeah, yeah.
The one thing you've got to look out for is making sure that it's a representative sample of the cable.
Yeah, yeah.
Because cable has massive variations. You know, you can't test one cable and then expect that certificate to last for the next 10 years, because cable manufacture can be done in several locations, it can be done in several ways, and this test doesn't care about your insulation, how many cores you've got, what fillers you're using. It cares about the gaps in the cable, and if those gaps aren't consistent through your manufacturing process, who's to say if you do a 10,000 meter run of cable, it's the same all the way through? It's probably not. So it's then capturing a representative sample of the cable. So you might need to send several samples for a project. You might want to be proactive and make the cable manufacturer do it. There's a lot of different routes to making this work, but if you don't want to use a barrier gland, you've got to do the test.
Yeah,
It's now mandatory.
Yeah, it'd be interesting to see how this pans out, actually.
The main problem is it's not the test.
It's a problem now for industry that's going to be worked out, I guess.
Yeah, change the process. It can no longer be done from a spreadsheet, from an office that's thousands of miles away from the installation. You need a sample of cable. That represents problems anyway, because it's quite late in the process. You're going to get that cable sample, and then you're going to have to establish whether it passes the test. Then you're going to need to know whether you need to order barrier cable glands or non-barrier cable glands. So the earlier you can do it in the process, the more proactive you can be, the more cost you're going to save, more problems you're going to save further down the line. But it's new, so who is going to do it?
Yeah, yeah, and I'm sure we'll find out as it goes. So,
Definitely.
are you preparing some guidance on this as well?
Yep, so we've got a plan to roll out over the next sort of six months, I think, where we're going to be producing some educational content, providing some training. We can provide guidance if anyone's got any questions, or we can come to their manufacturing location. We can arrange some bespoke training. We've got a lot of educational content going out, again, to raise competence, make people aware of these changes and how we can help.
Yeah, brilliant. That's good to have you here.
Yeah, good to be here. I'm really excited to be working with you.
Yeah, no, good to be working again together.
Yeah, again.
Great, all right, but thank you very much for your time. Thanks for watching, and yeah, we'll be back no doubt in the near future with some other topics. All right, thank you.
Thank you.